Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this East Chinese power inverters, and this is how it came to me by the owner. Now the owner of this unit, he is using it as a backup for running his surveillance cameras, and as he described it the other day, it was running fine at afternoon, and in the night suddenly it's shut down and stopped working. So he replaced the battery, and when he did, he smelled something is burning, and this thing literally catch on fire, and it smoked really well. So apparently he removed the cover, and here is the cover with the screws as it came to me in this plastic bag, and he searched for the reason or the cause of this burn smell and the fire and the sound that came out of it, and he found these transistors are blown. As you can see, these 4 transistors. Now this type of inverters, or in generally, there is 2 type of inverters in the market or in global market. There is the electronic type, and there is the transformless type, and there is the true transformer like this one. Now this type of inverter, it is a charger and an inverter in the same time. And there is also these days a numerous type of designs and builder qualities, and I believe this is the lowest of these. So what do I mean by that? Usually when you designed or when you buy a real type or high quality power inverters, they use and they adapt the design of a full wave transformer. But in this design, they adapt the design of a half wave transformer. And as an inverter it is okay, but as a charger, if you want to charge a battery from 6.5 volts, as they say in here, let me show you. Yeah, as they say in here, you have to take the power directly from the transformer and chop it and boost it up to a 12 volt or a 14.5 volt in order so you can successfully charge the battery. And this is will put a huge stress on the transformer in order to do this kind of job. So the design of this, it is a fail, but what you are going to do, this is the design that this set have, and this is the inverter that the owner have. So in this video I'm going to disassemble this board and try to find out why these transistors failed, and see if I can fix this inverter and bring it to a working condition. So without further ado, let's get started. So here is the board has been removed from the cabinet, and here is the connectors for the board itself, and you can clearly see that they use a lot of elastic in order to keep the jacks in their places and to prevent them from ever getting loose. Now this is a nice touch, and I really like that. Now taking a look at the board itself, you can see that there is two on this, two transistors in this heatsink and two on this heatsink, and there is four in here in this heatsink. So the four in this side, they had the number of 150 and 03, and the other transistors, they have the number also 150 and 03. So I believe they are using an 8 transistors in a different section of the circuit, 4 in this section of the circuit and 4 in this section of the circuit. So if I flip the board on the other side, you can clearly see that there is no damage, or there is no obvious damage in this side of the circuit, and I believe the only blown and the only burn traces are the transistors themselves. But before I install the new transistors in the circuit, I will have to test the component or the driving component of the transistors and see if they have any kind of damage in them, or if there is abnormal things, because I don't want to make a fool of myself and install the new transistors and they burn up as their previous transistors happened to them. So without a further ado, I'm going to try to do this and we will see what happens. So here is the PC board, has been pulled out of the circuit as you saw earlier in this video, and I remove all of the switch mode transistors from their places and I desolder them, and I remove all of the driver transistors for these transistors from their places. And apparently there is 4 are perfectly toasted, as you can see, this one and this one and this one, yeah, and these 4 ones are still good. Now the switch mode transistors, these two or the 2 SMDs, these two that they drive the main switch transistors, they are working fine, and these two are also working fine. And by taking a look at this circuit, if this camera will just focus, you can see that this resistor, it is toasted, and apparently there is another one from the other side. So yeah, the rest of all of the others resistors, apparently they are working fine, but I will have to pull them out and make sure that they are working fine before I apply any kind of power to this unit. Now, as you can see, it is okay construction, not the best, and yeah, apparently it works. In the end, you always get what you pay for. If it was for me, or this device with me, I will not buy this because of the crappy charging circuit. As a inverter circuit, it is okay and it is really good, but as a charger circuit, it is crappy, and this is why this thing failed in the first place. According to the owner, I talked to him and apparently it was stopped working, and when he replaced the battery, all of this burn up happened. So yeah. So what I'm going to do now, I'm going to pause this video and reinstall all of the transistors that I previously pulled them out, And after I do this, I will go ahead and replace all of the burned resistance and pull these diodes out on all of the other components and test them individually. And after that, I'm going to see if this circuit, when I power it on, it is giving the right oscillation, or the driver circuit in here, this board in here, it is giving the right or the correct signal to drive the switch mode or the MOSFETs. So yeah, let's get started. And we're back with the East power inverter. I tested the board using the oscilloscope and the frequency meter, and actually, according to the tests that I did, it is giving the right frequency in here, in the transformer driver circuit, and in the charger driving circuit. So I believe this circuit, it is working fine. So I go ahead and install all of the MOSFET in their places, and now I'm going to install it back into the unit and test it and see how it is going to work. And we're back with the East power inverter. I already assembled the board to the main cabinet, and I connected all of the wires to their places like it came from the factory, and I secured the screws very well and I tightened them very well. And now I'm going to power it on using a battery, and here is my test battery. This is a 100 amp battery, car battery, 12 volts, because this model, it is designed to run at 12 volt, not 24 volt. So without further ado, first of all, let's confirm that the switch, it is an off position, and this is off position. Let me connect I already connected the negative lead to the battery, and let's connect it the positive. Here we go. Let's flip the switch. As we can see, let me see how this will work. Oh, here you go. You need to push this button in here. Yeah. Power down. Oh yeah. There you go. The output, it is a 219 volt. So yeah. So let me turn it off. I believe this. Power down. Nice. So let me connect my drill to the output of this power inverter, and let's see how it is going to work. Until now it is working, but we will see. So here you go. Here is the, let me here we go. And even it has a neat feature that can tell you how much you are drawing of the unit. It is really good. battery, it is a little bit tired, but this is okay. So this allowed us to see if the charger or the charging circuit it is charging the battery or not. So let me plug it in to the wall socket or to the grid, power grid, and here you can, and apparently it is charging. So let me grab the DMM and see how much voltage as you can see from the sizzling sound. This type of charger, it is basically an inverter charger, so it is not a real type of charger. So yeah, the negative to the negative, the positive to the positive, and whoa. Now because the battery it is a little low in this VOM, we are getting 15 up to 16 volts. This is what happened in these kind of chargers. So let me grab my analog multimeter and see the results, if we have a different results or not. Here we go. According to the VOM, and because it is a half a volt low, I believe we have a 15 volts of power. So yeah, I believe the charger it is charging the battery really well. And now let's try to power on the drill on the AC mode. Nice, really nice. So I believe this power inverter it is now fixed, and I believe it is now ready to be delivered to the owner. So this will be the end of this video. I hope you like it. If you did, please like, subscribe. Thank you for watching. See you next time.